So let's do a quick recap of um, what distribution functions of a random variable are. Okay. Distribution function of random variable. So the idea here is we have a random variable. X is a random variable. Yeah. Then the distribution function of X as a function from R to R, right? So random variable, uh, if it's a single random variable, it is in R, and distribution function, it takes that function to, it is a function which is defined from R to R, which has the domain as R and the codomain is also R. So how do you define a distribution function? So we have to pay attention to the notations. F capital X is how we designate the function. Okay. Small x is the variable. This can x can take any numerical value because it is from R to R. Okay, that is defined as the probability of all x such that capital S is less than small x. So by the earlier definition of what the probability of a random variable is, we know this is all omega, set of all omega belonging to the sample space which that x of omega is less than or equal to small x. So one thing, using a distribution function, we can find the probability measure the probability measure of the random variable. Probability measure, we can mark it as px of the random variable. Okay. Now there are some properties. A function can be called as a distribution function if it satisfies some properties. Let's take a look at them. What are the properties? Use a different color. Properties of distribution function. The first thing is that distribution function, it lies between 0 and 1 for any x. So we know that x can belong to real line, right? For any x in the real line, the value of the distribution function always lies between 0 and 1. Second property is fx of minus infinity is equal to 0, which is actually something like an impossible event, and fx of infinity is equal to 1. Okay. Third is fx is non-decreasing. It may either increase or it can stay constant for a certain period of time, but it's non-decreasing. What does it mean? If x1, you're going from left to right of a function, if you have a function like x1 is less than or equal to x2, this implies the distribution function of x1 will be always less than or equal to distribution function of x2. So this is actually just like a recap. We have already seen these properties, or we'll handle this as a separate course. This is more like an advanced course on random variables. So fx is right continuous and has left hand limits. This is another property of distribution function. So if a function satisfies all these properties, then we can call this as a distribution function. So, and how is that condition? Yeah, is it a necessity condition or is it a sufficient condition? It is a sufficient condition, or you can call it as necessary and a sufficient. If the function satisfies all these properties, it can be called as random variable. Sorry, a distribution function. If it is a distribution function, it satisfies all these properties. It goes both ways, so it's necessary and sufficient, right? So some more additional properties. Additional properties. This actually helps us to find the probability of a particular point in a random variable. Yeah. So f of x plus, that's we are approaching a random variable from the right side to a point fx of x minus is equal to fx of x minus fx of x minus. Why this has same? Because it is right continuous. Why this is not same? Because they have jumped exponentials. They have left hand limits. Okay, that is equal to p of x is equal to x. Suppose we want to find the probability at a particular point. But one thing to notice here is that this is only valid when we have a discrete random variable. Because probability at any point is not defined for a continuous function. We can't specify probability of any point is 0 for a continuous function. So this is valid only for a discrete random variable. Okay. And another property is probability of a less than x less than equal to b is equal to fx of b minus fx of a. So if what does it mean if the random variables fall in between a particular range? So one thing we have to make sure is this is less than or equal to here, and it's a less than simple. So here it is continuous. Sorry, here it is closed and here it is open. Okay. How do you deal with the other kind of equalities? That is something else. Okay, we'll deal with it later. So these are the properties of the distribution function.